Welcome to the second part of section 2, where we are starting with the secant. And if you just think of the definition of secant, it's pretty straightforward from there. The secant is a reciprocal of cosine. So this is definitely, it may not look like it to you that this is the quotient rule because there's not an independent variable in the top. But if you think of it this way, it makes understanding it better. Because the derivative of the top is just 0, leave the bottom alone, except that denominator, like 0 times anything is just 0. Minus, leave the top alone, the derivative of cosine is negative sine over the denominator squared. Now we don't typically leave the answer like this, because what you can do is rewrite it as sine of theta over cosine theta, and now this is typically how we write the derivative of secant, because we typically write, I should have wrote this first, because we usually write the derivative of secant is secant from this piece, and then sine over cosine is equal to tangent against that piece right there. So typically we memorize that the derivative of secant is secant tangent. And again, we'll do so many of these that you will, I think, memorize them. But if not, don't forget about this rule, and you can work it out if you have to do it on a future AP test. So the derivative of cosecant is negative cosecant cotangent. And I had a student that was really good at memorizing things. This student memorized that any trig function that started with a c is going to have a negative answer for the derivative. So you can see up here the derivative of cotangent is negative cosecant squared. So if you can memorize one, there's definitely a pattern that the derivative of tangent secant squared, the derivative of cotangent is negative cosecant squared, the derivative of secant is secant tangent, the derivative of cosecant is negative cosecant cotangent. And it still works for cosine because the derivative of cosine is negative sine. So here's a few more. Find the derivative, apply the quotient rule. So just to work this out, the derivative of the top, 2x minus 2, leave the bottom alone. And then minus the derivative of the bottom is 1, leave the top alone. All over the denominator squared. Now, sometimes you can simplify it. Sometimes you can leave your answer just like this. Otherwise, you can, like if you FOIL this out, you'd have 2x squared. It'd be 4x minus 2x would be 2x minus 4, and then you'd have another minus x squared plus 2x. But most times when you do this, nothing special happens. So just to point this out, at the very bottom here, sure, 2x squared minus x squared is x squared plus 4x plus 4. Oh, this is kind of neat. I guess I didn't really recognize this. That if you look at this, that if you notice in the numerator, that's factored to be 2. Oh, no, I messed up. Yeah, nothing special happens because that should have said minus 4. And that's not factorable in the numerator. So I guess that's it. If you look at the function of p of theta, so p prime of theta, the derivative at the top is cosine. Leave theta squared alone. Minus 2 theta, leave sine alone. And all over the denominator squared. Well, when you square that, you multiply the exponents. Now this one I would simplify just because there's a theta shared in all three terms. So you could rewrite it as theta cosine theta minus 2 sine theta all over theta to the third power. That's probably how a multiple choice would answer that. If you're confused, let me point out that you could factor out 1 theta out of each of these. That's how it got there. So some more problems that we're just going to practice factoring. They're not factoring, finding the quotient rule. Derivative of the top is cosine. Leave the bottom alone. Minus the derivative of the bottom would be, well, the derivative of cosine is negative sine, so negative cosine is positive sine, and then leave the top alone. I'll just write it like that, over 1 minus cosine of theta squared. Well, if I look in that numerator, I think what you end up with is just a cosine of theta. Why? Well, how about this? You could factor out that negative, so this becomes plus all over 1 minus cosine of theta squared. And why did I do that? Because you should know by now that cosine squared plus sine squared is equal to 1. And let's factor out another negative out of that. So you can rewrite as negative of 1 minus cosine of theta. Double check my math here. Because then as I'm looking in the denominator, that term is shared, so we could take one of them out. So we're looking at negative 1 over 1 minus cosine theta. Kind of an interesting problem. So again, please pause the video, soak this in, make sure you understand. So I would actually rewrite the next one because I don't like that fraction inside of that. And then find the derivative. And now you can take the derivative of the top, which would be negative 1 times negative 1 is positive x to the negative second power. Leave the bottom alone. Minus the derivative of the bottom is 1. Leave the top alone. All over the denominator squared. Now here's the thing, is now this is sort of an ugly problem because as you distribute that negative in there, you're looking at adding the exponents. So we're at that 5x to the negative second power minus 3 plus x to the negative first power. I was hoping something would cancel. I'm doing this slightly different than the answer key. But anyway, we have 2 of these x to the negative first power, so I'm going to write 2 over x plus 5 over x squared minus 3 all over x plus 5 squared. And we typically don't leave fractions inside of fractions, so we can actually fix that by multiplying top and bottom by x squared. So now remember, it's a quantity to distribute in there. And the reason why you would do that is because then you can, you'd have negative 3x squared plus 2x, I'm looking at this term now, and then plus 5 all over x squared, x plus 5 quantity squared. So this is how I would work through that derivative if they asked me to simplify all the way. So go ahead and pause the video, make sure you understand it. And I'm about to share the answer key, which has a slightly different way of getting that answer. And he may even factor at the end. Let me find that for you. Yeah, he also factors at the end, which nothing special happens, so there's no need to do that. So you can see how he worked it out. Started by multiplying by x over x to get rid of that at the beginning. So feel free to pause the video and write down whatever you need to. And I'm going to move back to the notes. And yeah, now we're going to get into some graphical interpretations of things. So they tell you r of x is defined by this function, and f of x is in the graph. So if they ask you for the graph of f of x, or sorry, if r of x is increasing, decreasing, or neither, what we need to examine is what's happening at x equals pi. Well, we need the derivative first. So what's the derivative of x? Well, the derivative of the top is negative sine of x. You leave the denominator alone, minus the derivative of the bottom. You leave the top alone. All over the denominator squared. So now as we look at r prime of pi, remember that's about 3.14 on the unit circle. Pi over here is at -1, 0. So that means sine of 0 is 0, so I don't care what f of x is. It's going to be 0 minus, well, cosine of pi is -1. I better figure out what the derivative is at pi. Well, pi is about 3.14. It looks like this linear function. Well, anyway, the slope right there is definitely down 1, right 2. So I'm safe in saying that that slope is -1/2. Not really sure what f of pi is. Instead of approximating, you could actually find an equation of that line and get an exact answer. Like y equals -1/2. I should have picked a bolder color than that. Y equals -1/2 x. Looks like it would be -1. So if I were to plug in pi right there, I think I'd be safe to say that it'd be -pi/2 minus 1 being squared. But the point being is what happens in the denominator is once you square it, you get a positive value. In the numerator, you have a negative times a negative times a negative. You get a -1/2, right? I guess I could have just wrote negative in the numerator. So what happens when you have a negative divided by a positive? You're going to get r prime of pi to be less than 0, a negative value. Well, what does that mean? That means that r of x is decreasing. And there's your justification right here. X equals pi. Again, feel free to pause and really understand everything. Try it on your own, things like that. So instead of rushing through the last slide, and I'm going to stop right here and make a third video.